Hello everyone, Dr. Hassaan Tohid here once again with an amazing session on systematic reviews once again. And finally we are here, and I will try to finish this session in 1 hour almost. And let me share the link with all of you. I want to make sure everyone is here. So just forgive me for taking some time, because I need some time to send you the link. Okay, so now I'm sending the link to all of you. Okay, so let's begin. Okay, and I can see you guys are already here. And please do type questions. If you have any questions, feel free to type questions. I will read and get back to you. I will read and get back to you right away, because this is also a question answer session. And do introduce yourself when you are here. Please do let me know that you are already here. Okay, let's begin. Let's begin. So today's session is the phases of systematic review. I know many of you already know this, you have learned it, but many of you are still complaining that you don't understand exactly how things should go and how systematic review works. So we are talking about that today. Don't worry about it at all. Thank you, Rakshit. Thanks a lot. Thank you. And I can see you guys are here already. So just feel free to ask any questions. Anyone has any question, anyone is struggling with any question, do let me know. Okay, so how many phases of systematic review do we have? How many phases of systematic review do we have? We'll talk about that. First of all, for all the new admissions, congratulations on enrolling, and your actual classes will begin this weekend, and you will also attend my session every week. But next week I'm not available. Next week I'm not available, so I'll not have a session next week, but I'll compensate the following week by conducting 2 sessions. So I'll try my best to compensate. Okay, and for past 18 or almost 2 years now, since October 2019, yes, since October 2019, I have not skipped a single weekly session, and I have not skipped the monthly career coaching session as well. In fact, I have done more sessions, monthly career coaching sessions than usual. So just letting you know that I have not done it. And this week I'll be not available, I'll be gone. So I will not be present here, and I will compensate the following week by conducting 2 sessions. And there are so many things I want to discuss with you. I want to enhance your knowledge, and I want to discuss a few things that people are struggling with. For example, the research question, and how to select the studies, what to do. And those are the challenges that our students are facing, and everyone faces. That's normal. So don't get disappointed, don't get worried that, oh, I don't know this, oh, I'm scared of it. Don't worry about it. We will handle this today. The first thing first, I have noticed the main problem new people cannot learn research is because of the vocabulary. Because of the vocabulary. So what does that mean? It means that many researchers who are teaching research, they use difficult terminologies, they use difficult words, they use difficult literally difficult words and difficult terminology, and that confuses people, that scares them. So that's why I try to teach you in a layman language, and that's what it should be. That if you hear a new word, you should know what exactly it means. Like, for example, the word database. People don't know what database is. People get scared what database is. They get scared. Okay, so we have Roshni here, we have Anusha, we have Sabita, Tasneem, Asma, and we have Tejaswini. And Tejaswini, thank you. and we have a lot of people here. Thank you. So you guys are free to ask any question as well. I will answer your questions as well. So today we'll talk about, for all the new admissions, remember, the study design pyramid is the main thing that everyone should remember, the study design pyramid. Because to understand research, if you don't understand study design pyramid, you will struggle in research. You will struggle in research. I want everyone right now to draw this with me on the notebook or a journal or a diary that you have. Everyone, please draw a triangle. Hi Marhab, hi Faisal, Azra. Hi Johanna, how are you? So I want all of you to draw this kind of diagram. Everyone, ready? Please draw this diagram right now, because this is applicable to everyone, old students and new students. If you understand this, research and this training will become extremely easy for you. This will become extremely easy for you. So what does this pyramid say? This pyramid is all about research. If you understand this pyramid, you understand everything about research. That's the good news. This is a secret, I'm telling you. Any book you open after this about research, any lecture you hear about research, anything you see or hear about research after today, you will not have any problem in understanding. So study design pyramid is the main thing we all should start. I wish people had explained this to everyone before, and their students as well, that study design pyramid is the base. If this base is not clear, if this concept is not clear, you will always struggle. You will always struggle, and I don't want you to struggle. So what is this pyramid? I hope everyone has drawn this right now. Hi Nusaiba, how are you? Everyone has drawn this, and this I'm starting from absolute basics, absolute beginner. This is an absolute beginner's level, and for all the new admissions, I'm starting with absolute first thing first. Remember this, and your actual classes with your mentors will begin this weekend. But I wanted to discuss few things and take you to a higher level right before your actual classes. So this is my session, but your weekly classes on Zoom will begin this weekend. All the new admissions. So what is this pyramid all about? Study design pyramid. If you understand this, you understand everything about research. Good news. Everything in next 5 minutes. Yes, in next 5 minutes, you will understand everything about research. So how many kinds of research or research studies are there? If you understand this, you understand research. Like for example, in medicine, you have endocrinology, you have GI, you have rheumatology, you have neurology, you have different fields, right? Similarly, in research, we have just 9, or I would say a few kinds of study designs. That's it. If you understand each of those designs, you are #1 in research in the world. That's the great news. So don't ever let research scare you ever again. Only these things, and you know everything about research. So what does this pyramid show? It will show the strength of evidence. Write it down. Strength of evidence or strength of studies. The studies on the top are the highest quality studies, and as we go down, the quality of evidence goes down. The weaker studies will be at the bottom. The stronger studies will be on the top. What does that mean? What do we mean by strong? What do we mean by weak? That means the studies at the bottom have more chances of bias. Have more chances of bias. Bias increases from top to bottom. This is more biased. Lesser, 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 lesser. So not only bias, one more thing. The studies at the bottom are less relevant to human treatment. The studies at the bottom are less relevant to human treatment, and the studies at the bottom are weak studies as well. So this is something everyone needs to understand. The studies at the bottom are weak studies, and the studies are not only just weak because they have bias, but because of another reason. So there are two reasons they are weak. What are the two reasons? The bias, and they are less related to human treatment. So what is at the bottom and what is on the top? Let's talk about this. The studies at the bottom write it down. In vitro test tube research is at the bottom. So if you see a study design that has in vitro or test tube involvement, microbiology kind of research, those are usually the weakest evidence on study design pyramid. Why are they weakest evidence? Because not because it can have bias, mainly here because what if the scientist covers the bias and they are very, very vigilant about it? The main reason is it is less related to human treatment. After in vitro studies, what is next? Animal studies. Animal studies is the second from the bottom. The third from the bottom in vitro studies, animal studies. The third from the bottom is ideas, opinion, or opinion articles, opinions, or editorial. And this is very important to understand this. If you understand this, writing research article will become very, very easy for you. Systematic review will become a piece of cake for you. If you don't know other study designs, you will not be able to understand systematic review. If you don't understand other study designs, you will not be able to write a systematic review, which is the strongest research evidence. We are coming to that, okay? We are coming to that. Just be patient. The next one, case report or case series. Case report or case series. Then comes the three C's. All of these are observational studies. Everyone has heard this word, observational studies. If you don't understand what is observational study, then you can watch my YouTube video. It came few weeks back. Difference between study and experiment. If you watch it, you will understand what are observational studies. So right now, I'm not going into the detail, but I'm talking about the designs, the names you should remember. Cross-sectional. Cross-sectional study. Then comes the case control studies. And then comes the giant cohort studies. And cohort can be of two types. Retrospective, in which you go into the past. Prospective, in which you go into the future. Don't worry about it. You'll learn all this gradually. Now, the next thing is the study design that every IMG thinks that is the strongest research evidence. Randomized control trial. Randomized control trial. But randomized control trial is the second best. Many IMGs say that, oh, I want clinical research, I want clinical research, I want a clinical trial, I want to do clinical trial. But clinical trial is the second best evidence on study design pyramid. Why? You will understand why. You will understand why. Just now, you're about to understand this philosophy. Now, what is the number one? What is the strongest research evidence in the world? Systematic review and meta-analysis. Systematic review and meta-analysis is number one. Why? Because they are more related to human treatment and they have less chances of bias, because when you write systematic review and meta-analysis, you do the quality check. You make sure the bias is removed. That is why they are number one. In RCT, you can have bias. In randomization, in blinding, there are processes in randomized control trial that people do. So yes, this can have bias. Systematic review and meta-analysis have less chances of bias because you do quality check. I did not say that there is no bias. You can still have bias here. Now, what is left? Other kinds of reviews, scoping reviews. Should we bring it here? And traditional review. Two are left. Many people keep traditional reviews here. ID is opinion and editorial. But if you ask my opinion, I consider it really high. I consider it close to this, somewhere here. Because even a traditional review is not a joke. Because the strength automatically increases when you combine so many papers together. If you do a traditional review the right way, now this is very important to understand. If you do it the right way, it can be here. If you don't do it the right way, it can be here or probably down. Traditional review, that's why it's not in the pyramid. Because some people may put it here if it's written very well. Some people will put it here if it's not written very well. Depends on who does it. And scoping review as well. Where should we put scoping review? I would still do the same thing. I would consider the same thing with scoping review. Because there is no quality check in scoping review. There is no quality check. You will learn scoping review. I have made a video already on YouTube. It's coming very soon. I already created that video last month, so it's under the process of editing. So you will see that very soon. But what I suggest is, if you understand all of these study designs and you have them on your fingertips, You are on top of the world. You know everything about research. Unfortunately, people think that research is so difficult. But there is nothing more in research except this. That's it. I'm telling you a secret. From now onward, stop getting scared of the word research. There is either an in vitro experiments, in vitro studies, animal studies, ideas, opinions, editorials, case reports and series, cross-sectional studies, case control, and cohort studies. And these three, the three C's in green color, they are the observational studies. And the RCTs are also known as interventional studies or experiment. Write it down. RCTs are also known as interventional studies or experiment. RCTs are also known as experiment or experimental study or interventional study. They are the same thing. Don't get scared if you see a word experiment or if you see the word intervention. They're talking about RCT. RCT stands for randomized control trial. Randomized control trial. Very good question. Suchitra has a question, guys. I call this as experiment. And now I'm calling this as experiment. So are they the same thing? Is experimental and in vitro study the same? Which type of study is cancer cell culture study? In vitro is also experiment. But it is non-human experiment. So we can call it as experiment, but we cannot call it a clinical trial because the word clinical trial is only confined to human patients. When human patients are involved, you call it as clinical trial. And clinical trials have actually 4 names. Now I'm giving you one more name. Clinical trials have 4 names, so write it down. Clinical trial. Clinical trial. That's the first thing. Clinical trials are of 2 types, RCTs and non-RCTs. So randomized control trial and non-randomized control trial. Now what, oh wow, sorry guys. Okay, so number 3. Number 3, clinical trial, RCTs, non-RCTs. Both of them are clinical trials, randomized control trial and non-randomized control trial. Non-randomized, you don't do randomization, so that means there's a chance of bias. That's why we did not mention it here, because this is somewhere here, but we don't mention it in the pyramid. Just assume it's there. Assume it's there. RCTs, non-RCTs. The third name, interventional studies. Fourth name, experimental study. But I'll also call it experimental human study, because in vitro and animal can also be experiments. Experimental animal study and experimental in vitro study. So animal studies can also be known as experimental animal studies. In vitro studies can also be known as in vitro experimental studies. So experimental can be used for this, and this, the word experiment. But experimental human studies is only clinical trial, RCTs, non-RCTs, interventional studies, experimental human studies. So don't always think that the word experiment is confined to human beings. No. Experiment can be with anything. You have seen experiments, strange kinds of experiments in physics. So the word experiment actually means whenever there is an intervention involved, that means the scientist does the manipulation. When scientist does the manipulation to the environment and sees the after effects of that manipulation on the subject, that's called experiment or interventional study. So experimental study, human study, and interventional human study. So now the point is, can we use the word intervention here? And can we also use the word intervention here? Absolutely. But always see if the study is animal in nature, is it micro in nature, or is it human in nature? These are also human studies, but they are also done on animals. They're also done on animals. Anything can be done on animals, even on plants, any field. But we are just talking about the different words that you should be careful about. So if you see a word clinical trial, it means they're talking about human treatment with a drug, usually, or any intervention. Doesn't necessarily mean drug. If they're talking about RCT, they obviously are talking about clinical trial. Human is involved. Non-RCT, human is involved. If they say interventional study, it is highly likely a human study, but it could be animal study. So read it carefully. Is it animal, or they are still talking about human? Mostly it will be human. Experimental study, mostly it will be human in your domain, but it can also be animal and in vitro. So I hope I have answered this question, and now you understand the concept. So systematic reviews and meta-analysis are on number 1. Why? Because they have less chances of bias. They have less chances of bias. Because when you write them down, you check the quality of the articles to make sure that your paper does not have risk of bias. So everyone understands this? So now when you will be writing a systematic review or a traditional review or a meta-analysis, you can write a systematic review only of clinical trials. So systematic review can be of different types. Systematic review of clinical trials only. So yes, systematic review of cohort studies only. Yes, you can write it down as well. Systematic review of case control studies, systematic review of cross-sectional studies, systematic review of case series or case reports. Systematic review of these cannot be written. Systematic review of animal studies, systematic review of in vitro studies. So yes, you can do that. And can you do a systematic review of systematic review? That you just included systematic reviews in your paper and you combine all systematic reviews and you write one paper. Can you do that? Can you do that? What do you think, guys? Please type and let me know. Systematic review of systematic reviews. Can we write it down? Can you do that? Systematic review of systematic reviews. It means that you are just writing a systematic review with, let's say, 50 studies, and all of them are systematic reviews themselves. So can we do that? Absolutely, we can do that. Absolutely, we can do that. So systematic review of systematic reviews and meta-analysis. Yes, so it will become a meta-analysis. If it's meta-analysis of meta-analyses, oh my goodness, that will be a giant one. RCTs, systematic reviews of RCTs. Yes, systematic reviews of cohorts, systematic review of case control, systematic review of cross-sectional, case reports. So what you guys need to do is, if you want research to be in your fist, now listen to me, if you want to control the knowledge on research, that you want to know everything about research, Just read about these study designs. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. If you study these 9 things, you know 100% about research. Not 100%, I would say 90%, because two or three more things are left. What are those? Scoping review, mapping review. You will learn gradually all these. I'll teach you all these. Don't worry about it. Scoping reviews, mapping reviews, and what else? Scoping reviews, mapping reviews, and cross-sectional has a sister, longitudinal survey study. So total, you can say 12. Sorry, traditional review, 13. Total 13, 9 plus 4, total 13. That's it. If you read about these 13 things, if you this is very important. If you read about these 13 things and you know how each of these designs work, you know 100% about research. More than 99% people in the world. So the concept is clear. So one by one, just study about each of these designs. In this training, you're learning to write systematic review, scoping review, traditional review, and you will also learn mapping review. So these will be taken care of. But you cannot do a systematic review or meta-analysis if you are weak at clinical trial. So you need to learn clinical trial as well. And we will learn this gradually. You will learn all this. If your clinical trial knowledge is superb, if your clinical trial knowledge is extremely wonderful, you will never have problem writing a systematic review or meta-analysis. Now there's a question, can we term the systematic review of various systematic reviews as meta-analysis? No, systematic review of systematic reviews. But if statistics is involved, yes, you will have to call it a meta-analysis. Remember, a systematic review becomes meta-analysis. Systematic review and meta-analysis are interchangeable. Systematic review becomes meta-analysis if your paper is such that that statistics is involved and you have to use a software, then it's called meta-analysis. The name is changed, that's it. You do certain things in meta-analysis that you don't do in systematic review, like the forest plot heterogeneity. You also do funnel plot for publication bias. You also do bubble plot. But we are not talking about that. We have a meta-analysis, different course, you can learn all that. I don't want you to directly jump to meta-analysis. This is the last thing you should learn once your concept of all of these things is clear. Then you will enjoy meta-analysis. You will enjoy everything. It's so easy if your concept and base is strong. The problem occurs when people start to write systematic reviews directly or even traditional reviews directly, but they cannot differentiate between clinical trials, cohort studies, case control, cross-sectional, case report, and case series. They don't know the differences. So now let's talk about the differences quickly. In vitro, everyone knows. You all know what in vitro test tube research is. Name is given, test tube. When the lab has test tubes involved, that is an in vitro research. That is an in vitro research. You already know this. Now, animal studies, as the name suggests, will have rats, monkeys, guinea pigs, maybe some insects. We don't know what else. Animals involved, animal studies. Same experiments that we do on human RCTs, the same things can be done on animals. If it's a new medication you don't want to risk on humans, they risk it on animals. And there is an ethical issue, should we continue animal research or not? because we are unnecessarily sacrificing animal lives just to save human lives. So that's an ethical dilemma. We're not going into that detail, but it's common sense. You understand now, animal studies is also a reality. We discover new medication, we make new medication, and we test on animals before testing it on humans. So that's animal studies. Animal studies are also useful to treat animals in the future. That's why I am a firm supporter of animal studies, that you should do animal studies if you want to protect animals. If you have discovered a medication to treat a disease in animals, then why don't you test it on animals? Yes, then go ahead and do that. But of course, there are some ethics. Okay. So now you understand animal studies, you know in vitro studies. Now, ideas, opinions, editorials, these are simply ideas and opinions of experts. The editorials, the journal editor's expert opinion. It can have bias. That's why they are here. Traditional review, if a new person writes a traditional review, it will be like here. But if an experienced scientist writes a traditional review, that can be right here. That can be somewhere here. It can have a good value, because you cannot beat experience. You cannot beat experience. They know what studies to include, what not to include. And you gradually will become somebody of that caliber, that you will produce great quality papers. Now, this is done, right? These three are done. Case reports and case series. What are those? Case reports are case studies. Now the question, will a review about animal studies have higher chances of rejection? Absolutely not. Animal studies are beautiful. In fact, animal studies and in vitro studies, I was having a conversation with a very experienced scientist, and he said, in vitro animal studies, they can be extremely strong. People can get Nobel Prize because of these studies. They are very, very valuable. I don't know why the study design pyramid puts it at the bottom. Do you know that there is a comment I received from a scientist, and I totally agree with him. That animal studies and in vitro can actually be extremely valuable. What if the in vitro study that you conducted wins you a Nobel Prize? Will that be more valuable, or will that be more valuable? So never underestimate any study. Never underestimate any study. Now, case report and case series. Case report and case series. So case report is also actually the case study. Case study, when written, becomes a case report. Case study is when you are studying. This is very important to understand. Case study, many people say, I want to write a case study. It is about one person, place, or thing. You can write a case study on a person, a patient. You can write a case study on a city or town, a country, a community. You can write a case study on a thing, a unique person's thing, like possibly you can write a case study on the staff of Moses. Staff of Moses, peace be upon him. So you can write something like that. So person, place, and thing. Why do we do study on one person, place, or thing? To generalize on one person. Sorry, to generalize on whole population. We assume that this one person, whatever happened to this patient, can be applicable to multiple patients, although it can be wrong. That's why this is a weak evidence. Maybe that is the rarest case in the world, and you never see that case again. So you cannot actually generalize it, but this is an assumption of case study. And case study can be of different types: single case study and double case study. Yes, multiple case study. So yes, you can have multiple cases in one study, like a case study on the US and Canada and Mexico. So you're writing a case study on North America, so you write 3 cases on US, Canada, and Mexican economy, for example. Or you're writing a case study on 2 or maybe 3 reformers, Nelson Mandela, or what else can we say? We can Nelson Mandela or Mahatma Gandhi or somebody revolutionary, or maybe 3 dictators, Mussolini, Stalin, somebody like that. So you write, or 3 presidents, John F. Kennedy, Barack Obama, Donald Trump. You're writing a case report on multiple people. So yes, case report can be written on multiple people, but that is different from case series. Case series is something different. Case series and case report. First thing first. Now, case series and case report, what is the difference? Case series is when you have one group involved, and according to some experts, 6 people minimum. When you have 6 people, 5 plus people, 6 people minimum, that is a case series. Case report can be single case study, that means you have one person, or you have multiple people, and you compare these people with each other. But in case series is actually a study design. Case study can be a study design. Case series can be a study design that has only one group, so you can only do a non-randomized control trial. Yes, so it can actually become non-randomized control trial later. For example, surgical patients. If you have surgical procedure, you have discovered a new surgical procedure for brain tumor, so you cannot have 2 groups, a healthy group and non-healthy group. If you have healthy group and you are testing your surgical procedure, what will happen? You'll kill those patients. You'll kill those patients. Doesn't make sense. You can kill those patients. So that's why you can only have one group. So case series many a times can actually be a non-randomized trial of surgical procedures with only 6 people, or maybe a little more people, maybe 10, 11. Now there is one difference that we all need to know. Case series is often confused with cohort studies. So you learn all that as well. Okay, so now how do we differentiate the population sample, the sample collection, the patient or the sample collection, the data collection is outcome based. You collect patients according to outcomes. You already know the outcome. You already know the outcome. And then you follow up. You know the outcome, you follow up. If there is no intervention, let's say if there is no intervention, then it is not a non-randomized controlled trial. So it looks like a cohort study, because in cohort study, you follow up in the future too. Here you are following up in the future too. So what is the difference? The sample selection, the sample collection is outcome based. In cohort study, the sample selection is risk factor based. Here you know the risk factor. You don't know the disease. Here you know the disease. So these are the minor differences you need to understand about. Yes, that's case series. In case series, the sample selection is outcome based. The next thing is cross-sectional. Cross-sectional is very different than case series and case report. Why? Because in cross-sectional study, you are just looking at the incidence, the prevalence of the studies. It is also known as the snapshot. What is happening at one point in time? Usually, cross-sectional studies are survey studies. You collect the survey information. Now, I'm coming to a very important point. You have some people, a group of people, let's say 100 people, and you have given them surveys to answer. They give you the survey report, or you just observe them without giving any survey, you just observe them. So you're looking at the prevalence of certain behavior or certain disease at one point in time, that what is happening today or in 2021. So that is a cross-sectional study. But now there is a problem. Why can't we call it a multiple case study then? Aren't you confused now? Why can't you call it a multiple case study? Because there are hundreds of people involved, right? So why can't you call it a multiple case study? I could say that, right? I'll not call it a case series, because I'm not following up in the future. I'm not going in the future. I'm looking at one point in time. That's the main difference. And the selection is not outcome based. I have just selected a population, just like I selected a case here. So why can't I call it a multiple case study? You know the reason why? The hallmark feature of case reports is multiple sources of data collection. If you're writing a case report, if you have a case study and you just do a proper history of the patient, you take interview and you write a case report, that is not a case study. You have a flawed design. So the hallmark feature, now this is very important, please write it down. The hallmark feature of case studies is, or case reports is, multiple sources of data. Multiple sources of data. The hallmark of case series is only one group. Only one group, and sample is outcome based. That means we already knew the outcome and we collected the diseased patients already. Cross-sectional study is the prevalence study. Survey study, prevalence study. It can also have one group, but can cross-sectional study be of multiple groups? Absolutely. I have seen studies, multiple groups, so it can be two groups. It can have two groups too. And they are also known as descriptive studies. So that's why cross-sectional can never be case series, because case series has a hallmark of only one group. Only one group. Everyone is clear about it? Only one group. Case report or case study, same thing. Case study is a study that you conduct, and case report is when you write it down. Case report, and the word case report is mainly used in medical terminology. The case report is most of the time written about a patient. Now, multiple sources of data is the hallmark feature of case series. Case series can be of two types: single case study, multiple case study. But why don't we call cross-sectional study? Why can't we call cross-sectional study as multiple case study? Because there's only one source of data, the survey. Here you have multiple sources of data. Guys, I'm giving you that value that I've spent years to understand this concept. And I'm telling you with conviction, with challenge, nobody will tell you this. People don't know these things, unfortunately. It took me hours and hours and hours and years to understand this concept. So I'm giving you all of my experience today in one class. So cross-sectional, everyone knows cross-sectional study. So whenever you see a survey study, it's a cross-sectional study. Case study, when you have one patient, but always make sure that sources of data are multiple. And when you have one group, it is non-randomized trial, but is it a case series? Always see, is it outcome-based? Do they already know the disease? If they already know the disease, wonderful, that is actually a case series. And yes, you can also call it non-randomized control trial as well, because if there's an intervention involved, if you are doing an intervention, if you are giving an intervention, then it's a non-randomized control trial. But if there is no intervention, then it's simply case series. You are actually looking at the risk factor. You're studying the risk factor, but you know the outcome. Now, case control study, as the name suggests, it has two groups, case and control. Two groups, cases and control. The sample is always outcome-based. You all already know the disease, outcome-based. But this is outcome-based and this is outcome-based too, case series. So what is the difference? Remember, there was only one group. Here we have two groups. We cannot have a case control study without two groups. And then comes the cohort study. In cohort study, you go into the future. If it's prospective cohort, you want to see a group of people next year, following year, next year, next year, next year. The data collection was outcome-based. You collected a population that has a risk factor. Let's say you saw a population that lives in an environment where there is a poisonous water. So poisonous water is the risk factor. So you are just following them up. So you knew the risk factor, but you don't know the disease. The disease will happen later. And same thing in the past. When you go into the past, you do a cohort study. Yes, you know the risk factor, that there was something, but you know that something happened to the patient, but you don't know the disease yet. You study the disease. So in both cases in cohort study, you don't know the disease. You just know the risk factor. And you follow up in the future, and that one you follow in the past. And RCT, you always do an intervention. You give something to the patients, a medication. And the sample selection for randomized control trial, you need to understand a little bit of statistics. When you do that, we will teach you that gradually. Okay, don't worry about it. But that is it. That's the basics. Randomized control trial, the last one that is left. The last one that is left, actually, when you do sample selection, you do randomization. You want to make sure that everyone has equal chance of getting the medication that you're testing in the lab. Treatment. You divide them into two groups, just like case control. You have a treatment group and a control group. In case control, you had the cases, the disease, and a control group, non-disease. But here you have a treatment group and a non-treatment group. But we'll talk about clinical trial has way more things, and you should ideally learn about clinical trial. The stronger your clinical trial, the better you will be at writing systematic review and meta-analysis. Maybe one day I'll do a full session on clinical trials. Once you understand the concept, you will have no problem understanding. You will have no problem understanding any of the clinical trials after that. Now, the last question, what is the difference between traditional review and systematic reviews and meta-analysis? So there are three kinds of main reviews, right? Traditional reviews, systematic reviews, meta-analysis. Traditional reviews, if 10 people do a traditional review on different topic, on same topic, They all can have different results. Systematic review is not like that. You create a system. If I do it and you follow the exact same methodology that I conducted, I will record my strategy. You follow it and you will be able to get the exact same results. So you are producing a system, a machine that anyone follows can get the same results. Traditional review is simply written like an essay. No checklist or no guidelines are used. But for systematic review, you use Prisma guidelines, Prisma checklist, or Cochrane, or you use Cochrane guidelines. And you check the quality of all the articles you included, and you remove the studies with bias. Here, you don't check quality, no quality check. No quality check. And systematic review can become meta-analysis if you have studies that are similar. If you have similar studies, so that means there is a homogeneity. When you have homogeneity, you can do a meta-analysis. That means you can do statistics, but you will have to use a software like Review Manager or R or Stata. That's it. This is the main difference. Systematic review and meta-analysis are not different. Systematic review becomes meta-analysis. So every meta-analysis actually is a systematic review. But not every systematic review becomes a meta-analysis. Again, every meta-analysis was actually a systematic review. For example, every PhD was once a master's degree holder. So this is a PhD. Systematic review is a master's. That not all masters graduate, go on to do PhD. So remember this, systematic review is like a master's candidate, a person who has a master's degree. Some will go and do PhD, some will not do PhD, they will be happy with master's only. So when a systematic review goes to an advanced level, a little bit more statistical in nature, it becomes meta-analysis. And why not all systematic reviews become meta-analysis? Because if the studies are different, you cannot do a meta-analysis. And that's, by the way, first of all, it is impossible to have all the studies similar. It is almost impossible to have all 100% similar studies. So you will always have different studies. So that's why we always check. Meta-analysis actually is that you are checking, are these really similar? If they are similar, then you keep moving towards a statistical calculation. So that's how we do meta-analysis, that we are actually checking, are they really similar? This is a definition I'm telling you by experts. Many experts believe that the definition of meta-analysis is that we are just looking at if the studies we have included are really similar. So I gave you another extra point that nobody will teach you. So everyone is clear now? Now let's talk about the 3 phases. Finally, after an hour, we are on the main point that we started our conversation with. So I'll finish fast. 3 phases of systematic review. Yes, systematic review writing is so easy if you divide it into 3 phases. What are the 3 phases? Phase number 1. Phase 1 is planning phase. Phase number 2, write it down, guys. Phase number 2 is data collection phase. Or you can say search strategy. Search strategy. And phase number 3 is the writing phase. Systematic review has 3 phases. Phase number 1 is the planning phase. You plan your paper. Phase number 2 is data collection or search strategy phase. And phase number 3 is writing phase. Do you want me to write it clearly with a dark color? So let's do that. Let's do that. Do I have a different color? Okay, let's do that. This is not that good, so let's do black. Phase 1, 3 phases. Phase 1 is the planning. Phase 2 is the search strategy or data collection. Phase 3 is writing. Can you memorize it? PSW, PSW, or PDW. Planning, search, writing, planning, search, writing, planning, search, writing, planning, search, writing. 3 phases. Can you memorize it? So now how do you plan? The first thing first is the mental block. Always do your own psychotherapy. Always do your own psychotherapy by saying, I can do it. I can really do it. I can do it. I can do it. I can do it. Yes, I can write a systematic review. I can become a published author. It is possible. If I can become a doctor, I can do anything. Yes, guys, if you can become a doctor, if you can get into medical school, you can do anything in the world. Systematic review is way easier than passing your medical school exams. Way easier than that. I promise you this. Systematic review is way easier. If you have passed any of the USMLEs, USMLE exam is a king, is a giant. If you can do USMLEs, this is a piece of cake for you. Or forget about USMLEs, any international exam, or even your first year medical school exam. If you can do that, you can do this. We had 17-year-old students who did that. Did a remarkable job. High school students. High school students can do it, so you can do it, guys. How can they do it? Because they did not have the mental barrier. Remove the mental barrier first. Start to believe. The law of belief. There's a law of belief that says that whatever you believe with conviction becomes a reality. So believe in yourself that I can do it. Yes, I can do it. I can become a published author. Systematic review is nothing. I can do it. Systematic review is nothing. I can do it. Planning phase begins. You first plan and decide your topic. Once you have decided your topic, you will learn that during the classes. If you want to jump ahead, you can watch lesson 28 on your account. Everyone, make sure you have an account on the website. Lesson 128, lesson 144, lesson 148. You have planning phase, decide your topic. Then you decide your research question. This is by far the most important thing, because this will be your GPS navigation. If you do your research question right, you can do wonders. Half of your job is done. And research question is done by PICO format, or PACO. And you can add TS. So this is optional, TNS. We'll talk about this. Don't worry about it. PICO, P for population, I for intervention, C for comparison group, O for outcome. Or if you are writing a systematic review of observational studies. Population, E for exposure. Now see this? Why did I bring this? To tell you, to suggest this to you, that systematic review can be done of an observational study as well. Exposure, then again, the non-exposed group, control group, then outcome. Now, you want to make sure that it doesn't become a meta-analysis, because this is not a meta-analysis training. You're just writing a systematic review. So how do you make sure that your paper does not become a meta-analysis? It's kind of complicated, a little difficult for some students, but let me tell you a secret. If you remove the control group, highly likely it will not become a meta-analysis. Now, in some studies, you can have control group, because when you're collecting data, you cannot avoid it. Some studies will have control group, but if all the studies that you have collected will have control group, it will become a meta-analysis. So make sure you include studies, focus on studies that do not have control group or comparison group. Comparison group in the clinical trials. We're talking about clinical trial here. Comparison group, how do you recognize it? The placebo group, anyone who is taking placebo medication. Is there any group the scientist is talking about in the paper that people are taking placebo medication? Or is there any group scientists is talking about that has no treatment? Real control group, no treatment. And the last one is standard treatment. Is there any group that is just getting standard treatment? So treatment group is your group. The first scientist, let's say they have discovered something in a lab, or they're testing some medication. So standard treatment is something different. Standard treatment is what is happening in the market, what is already established. So let's say I discovered a medication. Let's say this is a medication for tuberculosis. The standard treatment is isoniazid. So this is isoniazid. So this is the treatment group. The treatment group will get this medication in the clinical trial, and other group will get standard treatment, and they will compare them together. That's a clinical trial. Another kind of clinical trial can be, you have the treatment group that you are checking. You have discovered a medication, you are testing that on one group. Second group is not getting anything. That is also a control group. Third one is, you have a medication, but you gave them a sugar pill, placebo. So do you understand the point now? So always be watchful when you collect data. It will be mentioned in the abstract. When you collect data, make sure that you stay away from control group, or majority of the studies don't have control group. Otherwise, it can become a meta-analysis. And now the point is, for meta-analysis, can meta-analysis be of observational studies? Yes, it can be, but very difficult to do. Mostly systematic meta-analysis mostly is done of clinical trials. So the planning phase, topic selection is done, research question is done. Now you work on your protocol. Protocol would be your planning page. You will already write a plan that what are you doing in the future. And then you register that on Prospero website. This is optional. If you want to do it, go ahead and do that. I will not stop you. Go ahead and do that. If you want to learn further and you want to register on Prospero website. Prospero is a website, people register their systematic review. Why do they register it? So that they can tell other scientists that, hey, stop, don't work on this paper because I am working on this paper. That's why registration is done. That's why registration is done. But it's optional for systematic reviews. and meta-analysis, but it's mandatory for clinical trials. So in the future, if you do clinical trials, that will be mandatory. But for now, remember, it's optional. And the reason I'm against it, I don't like it, the reason is because what if you change your mind and you forget to inform Prospero that you're no more working on this paper? It will be a mess. Nobody will work on that paper ever. Some scientists die in between. And they registered their paper, they stopped working because they died. So now nobody is working on that paper. Nobody is working on that paper. So the planning phase includes this. So if you want to register it, go ahead and do that. Once that is done, your protocol is done, your Prospero registration is done, your protocol is submitted to Prospero website, and that's called the registration. And that's the phase 1. Once phase 1 is done, you jump to phase 2. Search strategy. The search strategy, you do the data search on different databases, because a systematic review is a combination of so many papers to write one paper. A combination of so many papers to write one paper. The same thing is a traditional review, a combination of so many papers to write one paper. So it's actually a research where real patients, you are not dealing with the real patients. You are actually collecting information from already published papers and you are writing it down. One more thing I forgot to mention, in the difference between systematic review and meta-analysis. In systematic review, you do qualitative narration of your data, right? You write it down. But in systematic review, you know it is statistical, but you know what we do actually? We combine the results of all the studies. Let's say I have 10 studies, just for the sake of discussion. Okay, let's say 20 studies. I have 20 studies in my systematic review. One has 100 patients. Second has 2 patients. Third has 15 patients. Fourth has 3 patients. And fifth has 100 patients again. Sixth has XYZ. So we add the number of these patients and we do the calculation. So meta-analysis is actually the pooling of the results, adding the results of the studies and doing the statistical calculation to find one effect of these studies. So remember this. This is very important. One of the main differences between systematic review and meta-analysis. In systematic reviews, you don't do the numbers addition. You don't add the numbers like this, and you don't need statistical calculation. But in meta-analysis, you will do the pooling of results of each study, and you will do collection of patients from different studies. So imagine how big of a patient data you will have, patient pool, and you can tell if XYZ intervention is good or not. But you must need similar papers, similar studies. You cannot do that on different studies. That's why the studies should be homogeneous. Homogeneous means similar studies. And similar in terms of patient intervention outcome, patient intervention outcome, and ideally comparison as well. If all 4 are same in some studies, that is wonderful. This is a perfect systematic review, meta-analysis. But it does not happen all the time. It is not possible. So ideally, the closer the studies, close to similar, you can still do it. Anyways, that was meta-analysis. So now Planning phase was done. Now search strategy. To do the search strategy, there are a few things you need to remember. You need to search databases to collect papers. What do we mean by databases? Databases are websites like PubMed. PubMed and Medline are same. You can say same. Because PubMed is an interface for the indexing Medline. So PubMed, you cannot say PubMed is an index, to be very honest. PubMed is an interface to a database Medline. So that's number one. So can you rely on one database? No, never. You cannot simply search papers on PubMed. You know, by the way, PubMed has 22 million studies. PubMed has 22 million studies. So many people would say that if 22 million studies are present on just PubMed, why can't I just rely on PubMed? Remember, because there are so many good studies that are found on different databases, other giant databases like maybe PubMed Central, or the big one. The big one I would say is Web of Science. Web of Science, Science Direct. So always use at least 5 databases. Scopus, giant. PsycInfo. At least use 5 or 6 databases, 5 I would say. The reason is, if you just rely on PubMed in last 5 years, you just collected papers of last 5 years. You can kill the patients in the future. Somebody relies on your systematic review and they found out that this intervention is really useful. You included like 20 studies, but there were like 40 more studies that were against that medication in different databases. So your paper can kill patients. So please try to take it seriously. It's a matter of responsibility. And remember, the paper writing or career success, anything is directly related to the level of responsibility. Always ask yourself, am I full responsible of everything I do? Take 100% absolute responsibility of your life and your career and your paper. So your paper, you cannot afford to just rely on one database, because patients can be killed in the future because of your paper. Some doctors probably will rely on your systematic review and they trust the findings and they treat the patient, let's say in any country, any part of the world, and what if somebody dies? That's why it will protect you. If you use multiple databases, it will protect you. You will make sure that the findings are really, really accurate. If you're writing a traditional review, one database is enough. That's fine. But for systematic review, don't play. Don't play games like this of relying on one database. So now you do search strategy, but one more thing is left. You know what was that? You selected databases. What about inclusion-exclusion criteria? Yes, you have to have a predefined inclusion-exclusion criteria. Ideally, we do it here. Inclusion-exclusion criteria. But I know some scientists, they first collect data and then they select their inclusion-exclusion criteria. And then they remove the studies that were useless. I would recommend to initially decide it in the planning phase. What kind of studies will you include? And how will you decide your inclusion-exclusion criteria? By your research question. You will decide your inclusion-exclusion criteria by your research question. Your research question is your GPS. Remember the navigation I mentioned? So your research question is the guide of deciding inclusion-exclusion criteria. You will focus on male patients or female patients. You will focus on last 5 years of studies or last 10 years of studies. If you're finding a lot of studies in just basic search, scoping search, that means you need to reduce the timeline to last 5 years. If you're finding too little studies, then expand the inclusion exclusion criteria to last 10 years. So be flexible with your inclusion exclusion criteria. So there are two ways to decide a good inclusion exclusion criteria. What are the two ways? Look at your research question, get ideas from your research question. But the second most important point is look at similar papers to your topic and go and see what inclusion exclusion criteria have these scientists, other scientists have used. It can give you a lot of good ideas that, okay, that's how inclusion exclusion criteria is done. So you will just focus on those studies. Now, why do we use inclusion exclusion criteria? To make things easier so that we can have limited number of papers to search from. Because if we don't have inclusion exclusion criteria, we will have humongous amount of papers. It is impossible to search. Now, some people say, what if I if I mention a good inclusion exclusion criteria and I get some studies, let's say 200, 300 studies finally, to select my final 50 studies. So what if I miss some good studies? The answer is, it's okay. Everyone knows that you used an inclusion exclusion criteria. So those good studies were removed deliberately, and your inclusion exclusion criteria will tell future scientists that what inclusion exclusion criteria should they focus on so that they can find other studies that you did not find. So it's okay. It's okay, don't worry about it. Okay, and then after that, databases and inclusion exclusion criteria is confirmed. You selected studies. You do your mesh strategy for PubMed plus the keywords. And you will learn that during the classes. And you can also watch one of my videos on YouTube, 2-part videos on mesh strategy. You will understand how it is done. And then you also do regular keyword search on other databases. Once you find a total number of papers, let's say 1,000, now the next thing is you remove duplicates. You remove duplicates. Then the next thing what you do is once you remove duplicates, you start screening. First and second author will start screening. You screen the records. That means the titles and abstracts. And then once that is done, you screen full text papers. You call them reports. Records and reports, do differentiate between them. Once that is done, you check the quality of the studies by using quality appraisal tool. All of this you will learn in this course. How to do all of these steps. Don't worry about it. Don't get scared. Just remember the steps for now. Just remember the steps on fingertips. You do the planning phase. You do the search strategy. In search strategy, you decide databases. You have your inclusion exclusion criteria already. So now you do your search strategy. PubMed will be mesh plus keyword search. And then the other databases, you just search keywords. And now then studies that you will include, let's say final studies you have found like 1,000, then you remove the duplicates because you use multiple databases. So you will have some duplicates. You must remove the duplicates. Once you do that, then you do the screening, and screening will be done by 2 people, first and second author. Records and titles, and whatever final number is left after you excluded the studies that were irrelevant, now you find full text of those papers. You will not be able to find full text of all the papers that are left. So whatever you can find, just look at the full text. Now further screen, 2 people will screen and see after reading full text, do we really have relevant papers? Then you will have hardly like 60 or maybe 40 or 50 papers left. Then you will do the quality check of those papers. Each paper that is left, you will check the quality. How do you check the quality? By quality appraisal tool. You will learn that during the training. Don't worry about it. Once that is done, the next step is, after quality appraisal is done, the next step is data extraction. You extract the data on a data extraction form. You download data extraction form from Google, and you have the data compiled in an organized table format and you will be ready for phase 3. Now, phase 3. Phase 3 is the writing phase, the last phase. In the writing phase, what do? You make sure that you open Prisma checklist and make sure you write your paper according to Prisma checklist. Nothing is left. That's it, simple. How many words? 3,000 to 5,000 words of full paper. Okay, you can choose 3,000, 4,000, 5,000. And the total number of references, I would say minimum 30, minimum 25, maximum go until maybe 100. 50 to 100. 50 is also a very good number. 25, 50, or 100. 50, ideally, it will be a shorter paper, easier to write. 4,000, 3,000 to 4,000 words, 50 references. That means total 50 studies you included, and you start writing. And the writing is done according to Prisma checklist. And Prisma checklist is available free of cost, totally free of cost on Google. Just which Prisma checklist? Prisma 2020. And the requirement for Prisma 2020 is that you draw Prisma flow diagram 2020. And I discussed that last week. Remember? If you don't remember, go on this same channel. I haven't removed it. You can watch the Prisma flow diagram 2020. So while writing, once you complete your writing, you will learn all these writing steps. Don't worry about it in this training. You will learn all this. Just make sure that you also draw Prisma flow diagram. And here we end our 3 steps of systematic review, the 3 phases. So the first phase was the planning, second phase was the search strategy or data collection, the third phase was writing. So that's it, guys. Thank you. And here we are done. So anyone has any question before I leave? Okay, so Lubna has a question. What are the phases of clinical trial like COVID-19 vaccination? Some are phase 1, phase 2, phase 3. Clinical trials have different phases. Those are not systematic review phases. Don't confuse them. Clinical trial has 4 phases. Phase 1, phase 2, phase 3, and phase 4 is the final phase before the drug is officially launched and accepted by FDA in the US. So we have 4 phases of clinical trial. When a medication or vaccine goes through 4 phases successfully, then FDA usually approves the medication or a vaccine. If it doesn't go beyond phase 1, phase 2, phase 3, they don't approve it. So we will learn that in the clinical trial. I'll discuss that someday. Okay, everyone is clear about it? Anyone has any question before I leave? So these steps will be discussed in more details in the Zoom sessions, right? No, I will discuss that, but you don't need to know steps phase 1, phase 2, phase 3 of phase 4 of clinical trials. It is not needed for systematic reviews. To understand systematic reviews, you don't need to know the phases. You can still do it without it. But all these that we discuss, all these phases, Johanna, all these phases that I discussed, planning, screening, the data search, and writing, you will learn more and more about this each week. We will expand and give you more details. How to do your planning, topic selection. The first week is topic selection, of course. Then the search strategy, how to do that, the data search, and the duplicates removal, the screening, the quality appraisal, data extraction, and then the writing. That's how it is done. So you will be an expert, I'm telling you. You know, many of our students go on to become our faculty members. So you will learn this much that you will actually be teaching others. Okay? Not necessarily with us, but probably you will be able to help others. This is what the goal of objective of this training is, that you become that good at systematic review and traditional review and research that you will be able to guide others in the future. Yes, you have just joined everything. You will get everything on your account. Don't worry about it. Okay, don't worry about it. You will get everything. And I'm not deleting this lecture, so don't worry about it. Okay, thank you guys. Thanks a lot. And we will meet again after 2 weeks, because I'm not available next week. I'll do a couple of sessions after I come back, and we will go deeper in each of these steps. We can further expand so that you also enjoy my sessions with your mentor sessions. You will have collective combination of 2 teachers, so you will enjoy that. Okay, so I'll expand on each of these gradually. Okay, so I hope you guys enjoyed today's session and you guys learned something, and now you're feeling confident that you can do it. That you can do it. Simply, guys, if 17-year-old can do it, you can do it. It's so easy. If you memorize these 3 phases, these steps on fingertips, you are 80% done. And then the task is really easy. It's not difficult. Okay, thank you guys. We'll see you again very soon in 2 weeks. And until then, goodbye. And you guys have my WhatsApp number. You have any question, if you have any question, feel free to send me a text message. I will reply as soon as I can. Although I have a busy week next week, I'll not be here, but I will make sure that I reply. Okay, thank you guys. Thanks a lot, and we'll see you again.